So yeah, it should be done by 5. But if I'm going too fast, let me. Oh, yeah. All right. So let me create this class. What is it supposed to be called? Store item. Now, store item is a abstract class. So it's an abstract. All right. Now on the UML diagram, so this is tutorial 7. A lot of you guys probably didn't get to do tutorial 7 since that was the week this whole COVID thing started. So this might be a good tutorial. Pay attention. So yeah, based on the UML, they had number signs on the thing there. Besides the attributes, that just means that it's protected. So the item ID, the item description, and we'll have the price. All right, cool. So let's create a constructor for that. Oops. All right, so that's it for the constructor now. It says it has 2 abstract methods, cal tax and cal final price. So those 2 return double. So we just say public abstract double cal tax doesn't accept any inputs, and calc final price. All right, so those are 2 abstract methods. All right, that's it for store item, believe it or not. So let's move on to the next class. So there's a child class under the store item class called local product. There's no attributes inside it. So I'm going to figure that this is just another abstract class. Well, I'm just assuming. I'm just gonna make it abstract. But since this is a child of store item, we can say extend store item. Okay. So it doesn't have any special attributes of its own. But again, it's gonna need a constructor, and it would need the stuff that we have here inside local product. Yeah. So let's just call super and pass over all of these. All right, so literally that's the only thing in that class. We have a class called imported that also extends from thing here. In the actual tutorial, I didn't actually have to do this much, but I'm just doing this so that it will actually compile and work. Because I mean, a lot of times it's not actually compiling. So local called imported also extends from thing. It has one unique attribute. So I made this a thing here. So import duty. Um, basically, oops, the same sort of constructor here. So it's gonna have to accept uh, import duty. This dot import duty go import duty. All right. So that's it. Now after that, we should get to the local product in consumer product. Now consumer product extends. Well, consumer product is a child of local product, and food is a child of local product. So consumer product Java. All right, so this extends local product. Now, if you notice something here, right? Local product extends store item. Store item is an abstract class, but yet still I'm not providing any implementation for calc tax and calc final price inside consumer product. I mean, inside local product. The reason why I would not have to is because local product is also an abstract class. So if the class that extends the abstract class is also an abstract class, it does not have to provide implementations for these abstract, which is why I made this abstract so I can show you that effect. All right. All right. So again, let's create a constructor for this. It's gonna basically look like this. So let's change this. Consumer product. All right. Awesome. You should be good to go now. It says implement the calc tax and calc final method for the consumer product class. Calc tax method applies a fixed tax rate and returns the value of the tax, while calc final price combines the tax and the price to give the final total. All right. What did you say the tax rate? Oh, the tax rate is 16.5. So since this is a concrete class, this extends the abstract class. It's going to now have to implement the abstract methods that this should have implemented, which is, well, this would have implemented. Basically, the abstract methods that this inherits. So it's going to have to implement calc tax and calc final price. So I think this just returns the tax multiplied by the price, I think. That's what I call it. Yeah. So it's protected so I can access it directly like this. So calc final price now just basically just is the tax plus the price. Yeah. Natural ordering for store items based on store item ID. Store item implements the comparable interface. Implement the compare to method for the store item. All right, so back to store item. Now it says it implements the comparable. So of course, comparable store item. So of course you have to override this method here. All right. So basically, yeah. So basically, again, this is gonna return 0 if they're the same. Blah blah blah, so on and so forth. Now we're comparing the item IDs, right? Now we could go through the trouble of saying, you know, if item ID is equal to other.item ID, return 0 else, da da da, greater than that, da, da, da. Yeah, waste of time. Luckily, there is a compare to method in the integer wrapper class. So there's some ways I could go about this. So I can say this. Right. Now, if you notice, the item ID here is a primitive int. Now, I am not able to do this. I can't say item ID that compare to other. So other.item ID. I can't do that because item ID right here is a primitive int, so it does not have access to methods. So it can't do dot compare to, which means I need to convert the item ID here to a integer, a wrapper integer. So all I have to do is just say integer, let's say my ID equal item ID. And then I can simply just say my ID dot compare to, and then say other dot item ID. Now that works. All right, that literally works. So my ID is a wrapper integer, has a compare to method, which takes in a integer and will tell you which one should. It will basically return the thing that you want to return, which is 0 if they're the same, so on and so forth. Right? Now let me show you how you would do this if, for example, we did this instead. Let's say we did this instead. We didn't specify the type. So what we had here was your object, right? Cool. Now what we would have to do, if I tried compiling this right now, it would not work. Reason being, other here is of type object, which means it does not have a attribute called item ID. It would not compile. So what I have to do, I would have to do something like this, which is called casting. And then it will work. Now this should actually compile because you're basically converting the type here of other from object to integer. So then it will compile and get this. Alright? So just certain things to look out for. Alright, so I showed you like 2 or so ways, different ways to do this one problem. Alright. So yeah, that's it for the compare to. So let's move on. So there's also compare to for strings, floats, doubles, so on and so forth. Now food may be alternatively retrieved or ordered based on price. Implement a comparator class called compare by price that will allow searching for food by price. Okay. All right, so this is a comparable interface, which means you have to implement the compare to. Now we're gonna look at something else called comparator. So I'm gonna create a new class, and I'm gonna call it compare by price. Compare by price. All right, so we compare by price. Now let's say the compare by price here is supposed to implement the comparator class. So implements comparator. Again, we can specify the type of what we're trying to compare. Yeah. Now the comparator in this case, let me just look to see if it takes two types. Okay, so yeah, one type. So we're going to make it compare store items. I know it says food, but since food is a store item, and since we're going to use it to compare foods really, store items, then it's best to use this. Since our food is a store item. Now, if you implement the comparator interface, you must override the compare. Now, this method is just going to take two objects of whatever type you specify here. All right, so let's say we'll call this first, and let's say we'll call this second. Cool. Now, what is it supposed to do? Again, based on the tutorial here, it says it will allow for sorting by price. So this essentially is going to compare the price of this thing here to the price of this thing here. Now, to use a comparator interface, I think we'll have to import it. So java.util.comparator. This. Yeah, so I'll have to import it. All right. So again, it's gonna return 0 if the price here is the same as this. It's gonna return -1 if the price of this becomes before this, and so on and so forth. So again, the prices are doubles. So the wrapper class for double has a comparator method. So we will literally use that. So, well, first of all, let me get the two prices. So let's call this first price equal first dot get. All right. Now, if you notice, we're in a separate class. So here's what let's well, the proper way of doing this is actually to create a get price. Where is the stored item? So let's just create a get price. Yeah, so saying first dot get price. I don't let you. I'm gonna call it P1 and P2. Whatever it is, long names. All right, so those are two prices. So this is the price of first store items, price second item. So you need to determine which one should come before next. So simply just say return p1 dot compare to p2, and that's it. Yeah. Again, if we had not specified the type here, so just say comparator. Both of these would be of type object. And if that's the case, then I couldn't do this. I would have to I would have to do the classic 482. Alright, so that's just two ways of doing it. If we don't specify the type, those two are going to be of type object. If we want it to compile, then we need to do it. Alright, let me just undo all that. Awesome. So that's a comparison. Basically, what usually happens when you're doing a sort, as I said before, it's going to use the compare to method to see how to sort stuff. Let's say, for example, you don't want to sort it by whatever condition is specified here. You want to sort it by some other condition. You can create a separate comparator, specify what the sort should be about. And then when you're doing the sorting, you can pass what your comparator is so that Java will use this instead of the default thing for sorting, which you'll actually see an example of when we get to this. All right, so I think well, let's just create a food class as well. The food class is literally going to be a carbon copy of the consumer product class. Um, well, no, it says food items do not attract a VAT. Okay, so the food items for no consumer. Yeah, so let me copy this. It should be food. So the tax will actually be $0. Yeah. All right. So let's write the tester code. All right. All right. So this is up. All right. Right, so let's create two lists that can hold store items. The first list should be an array that can hold a maximum of 5 items. Second list should be an array list. Okay, so store item, items 1, new store item. So it says it should hold a maximum of 5. I'll have another list where item. And this is another list. All right. It says add 2 food items, 2 consumer products, and 1 imported product to each list. Now remember, this is a list of store items. So all of those products that I just listed, the food, the consumer product imported, are all store items since they all inherit either directly or indirectly from the store items. Is there a tutorial for this? Is there a tutorial for this? Anyways, yeah. Oh, polymorphism. Yeah, I'm supposed to explain polymorphism. Yeah, I'll explain that soon. All right, so it says add two food items to the okay. So of items 1 at 0 equal new what is this? Food. Ah, no. All right, so of two food items, so the food must have a item ID description, because yeah, I'm just writing some random stuff. It says two consumer products. So consumer products basically same thing. The last one is imported. So imported has all of these things here plus the import duty. All right. Supposed to be the same thing for the next one. So yeah, just leave those two the same for now. All right. Now it says sort both collections, the array by item ID and the array list by price. Um, all right, so to sort, we're gonna have to use the collections. We import java.detail collections. Yeah. Now we want to sort uh, the array list. Oh no, they say yeah, sort the array by item ID and the array list by price. Now to sort the array, we have to use a class called arrays. So to sort the array, we'd say arrays dot sort, and then pass in the array that want to sort. In this case, uh, that's items one. All right, so that sorts. So what is that gonna do? Now here it says sort by item ID. Now I already going to say arrays that sort, right? It's an array of store items. How does it know it's supposed to sort them by item ID? Well, it knows sorting by item ID because the store item class is comparable. which means that it implements a compare to method. So it's going to use this to determine what is it going to use to sort. Now clearly we can see here we're using the item IDs to determine the sorting. So that's how it knows to use the item IDs to sort, right? Now it says I want to sort the array list by price. Now to sort an array list, we use the collections class. So it's a collections.sort. Now, if we just wanted it to sort by item ID as with the array, that's all I would do. Let's say collections.sort item is 2. But they said I want to sort by price. How am I going to achieve that? Luckily, I created a comparator called compare by price that basically specifies the condition for sorting by price. Collections.sort has the optional argument of specifying a comparator. In fact, let me show you. So we have two, it's an overloaded method. So we have two sorts. So we have one that just takes a list, and one that takes a list and a comparator. So that's the one that we want to use. So items, 2. Now the comparator, we need a comparator object. So we create it. So it's a new compare by price. So this is another good example of how interfaces come into play, because the collections here expects a comparator, and we know comparator is an interface. The collections class can be assured that this compare by object here will have a compare method. So when the collection class calls this compare method on the compare by price object, it knows for sure that it will work because the comparator is an interface that forces this class here to implement this method with this specific definition. So this is another example of how comparators communicate. Now I've been typing out the code, but I haven't actually been testing this out. So let's test it out and see actually what's happening, right? All right. First of all, to test this out, let me actually create a new string. So ID item ID and then I've got the description, the item description, and then we have the price. All right, so over to string there. So it's okay. Yeah, so over to string right there. All right, so what I'll do is actually print out these two arrays for item system print item. And I'm gonna do the same thing for items 2. All right. So this goes item. Yes. So So we've written a bunch of code. Clearly don't know if it works. It's not really a good idea. We tend to best practices to test as you go along. But, yeah. All right, so Java start Java. I'm sure there's an error somewhere. Yeah, exactly. Imported. Yeah, exactly. We didn't even extend store item. Woo! Can I find symbol array list? The importer. All right, let's go again. All right, so it says import is not optional, does not up. Oh, calc final price, yeah, and store item. Yeah, so if you notice the what is it? Imported class here is not an abstract class, um, and it extends store item, but it did not provide a implementation for calc, calc price, and calc tax. So we need to basically provide an implementation to it. So here's what I'll do, I'll just copy it. Let me see, da, da, da. Where am I, where am I, where am I? Imported, right? Yes. All right, so let's do this again. Compile, nice. All right, so let's run this and so. All right, so it's sorted. All right, so let's look at the first thing. So remember, the first thing is sorting by item ID. So as you can see, the first one here, ID 2. Oh, oops. Let me put a slash in after here so that, well, although, this is print ln. Aren't I using print ln? Lol, is that the first time in a while I've used print? So what? Lol. Okay, okay. I got you. No need to worry. Don't panic. Keep calm. Yeah, let's compile again. Awesome. Now look at the first list. In fact, let me, so that you guys can see things better, let me separate them. Some of the system, the out, the print, list 2. Yeah, so list 1. Now if you notice, list 1, it's sorted by IDs. So the first one's ID 2, then ID 3, then ID 4, then ID 6, right? Then ID 8. Even if I had inserted it in different orders, right? Let's say I did something like this instead. So let's say I change this to 2 and this to 1, right? It would still sort them in the correct order. just to prove it to you. So see, we have ID2, then ID3, ID4, ID6, and then ID8. Now let's look at list 2. And if you notice list 2, this one is going to be sorting by price. So the first one is this one. So it starts out with the lowest price at 154, then 232, 456. Probably should have used a different one for this so you guys can see. 476. You guys are seeing my terminal, right? Like it's visible. Yeah.
Yeah.
Okay. Yeah. So look at this. So you have 154, then you have 232, and 456, 476, 654. Yeah. Now, to reinforce the point I was talking about, if I did not specify the comparator here, let's see how it would have sorted it. See? Sort it in by item ID. So basically, if you do not specify a comparator, the order that it will sort in is based on the order specified by the compare to method from the comparable interface. All right, so let's move on to the next thing. Now it says use binary search to find an item in the array list by price. So what's this binary search thing? All right, so collections have something called binary search. Yeah, so binary search takes a list. It takes the object that you're searching for, um, and as comparator if needs be. All right, so it says we want to search by what? Price. So we're gonna have to specify a comparator. Now the list that we're searching through is it says the array list, right? Yeah. So searching through items too. You're probably wondering, okay, what are we gonna put here? So what is this binary search basically supposed to do? It's basically just return the index position of whatever we specify here. Now basically, let's say for example, I wanted to find the position, or basically I wanted to see if there is a store item in my thing there that has a price of 456. Or I want the position of the item at 456 as a price. What I would do is this. I would create a store item. You can call it whatever one. Let's just call it to find. Um, um, so you saw I almost made a thing there, cardinal mistake a while ago. Saying new store item. Of course, I can't say new store item because it's abstract. So I have to use one of these like food or whatever. Now, basically, for this to work, you just need to create a store item object or something like that that has the price of whatever you're looking for. So if let's say for example I'm looking for the index position of a food item or some item store item with a specific price, all I simply do is just create an object with that same price. You can put whatever you want for the other stuff. So let me just put some like 0 for this and I don't know, like gibberish for this. But the price, that's the thing that you need to specify the exact number that you're looking for. So we're looking for the one with, let's say, 476.1, right? So that's what you put right here. You put that object right here. Now, since you wanted to search by price and not by item ID, you specify the comparator, compare by price. Now this method here is going to return an integer that represents a position. Now I think how it goes is that if the position or the thing does not exist, then it will return -1. Now, because this is a binary search, it is imperative that the list is sorted beforehand. So instead of realize that we sorted the list by price beforehand, the binary search works on sorted lists. So we have to sort it first, and then we can use the binary search method. A binary search is a more efficient version of sort, or searching, I should say. So let's actually print out what position this thing comes up with. All right, so see there, it's found it at position 3. Well, let's see if it's right. One, two. Well, I guess it uses the it doesn't use like we call it. But let's test it out. Let's try out this one. Yeah, so it's not 0 position. So the position that returns is like 1 represents the first one, 2 the second one, so on and so forth. Yeah, because as you can see here, it returned 1 because that's the first one. So we're looking for the one at 232. All right, that's it for that. Let me see what's next. Now it says compute the total price of each item in the array and generate the bill total. All right, so basically they want us to go to all the store items. In the array and calculate the final price. So it's basically a simple for loop. So we're saying final price plus equal. We need to get the price from each of these store items. So it's a it dot calc final price. Is it called calc or cal? Calc. Yeah, calc final price. Again, we can be assured that every store item in this thing here would have implemented calc final price in some way, given that they are abstract methods. So we know this works. So let's print the final price. All right, so we're gonna compile. Nice, compiles. All right, see there. Final price what am I doing? Final price 2162.688. Yeah. Now it says to identify parts of the code that are polymorphic. What do I mean by polymorphism? Basically, polymorphism describes behavior wherein a class can take on several different behaviors. Now, We have this class called store item. We have classes called food, imported, whatever, right? Now let's look at the food class, right? We know a food is a food, but a food is also what? Food is also a local product. Food is not just a local product. A food is an imported. Means our food is a store item. So we have this one class that can essentially take on several forms, can be one of many things. Now, polymorphism basically is observed, especially when we have method overriding. Now we have a list of store items here, right? Now these store items can include several different things. A store item can be food, could be a consumer product, could have been imported. Now for all of these store items, we are calling the same method, calc final price. Now even though we're calling the same method, calc final price, what actually comes out of this, what's returned, is different or varies based on the actual object that is actually being executed. So although at compile time, Java sees all of these as store items, at runtime, what Java will do is execute the method that is overridden in each of the classes or the actual objects that we have here. So even though we have a list of store items, when this is printed, the calc final price method here is printed, the behavior of this method will change or basically mutate, kind of like a chameleon, based on whatever object is present at any point in time. So let's say, for example, right? So let's run this loop again. Um, let's say we have a method called print hello, right? Print hello. Let's just call this. Uh, so yeah, let's just say the method is called print hello. Um, so I'm gonna create a method called print hello. Now, just imagine you are a store item, right? Store item print hello might look something like this. System.out.print. In fact, let's just make it return to. So return hello. I am a store item. Right? Simple enough, right? String. Yeah, simple enough. Now let's move over to the other stuff. Let's move over to food. So let's override this inside food and consumer product. Hello, I am a food. Let's do the same thing for consumer product.
I just want to point out that
Yeah.
statement is completely normal.
What?
It's completely normal.
So here we have one that says, hello, I am a consumer product. And I think we have an imported one. This one can say, hello, I am imported. I guess that's normal too. All right, so let's see what happens. So yeah, so I'll say system. Oh, that print. Um, All right, so this here is another example of polymorphism. So we have a list of store items, but we're gonna have different things saying hello at us. So we hear the Java compiler say, oh, these are all store items, but all these things are saying hello. So I'm saying, okay, I'm gonna expect this thing to be saying, hello, I'm a store item. Hello, I'm a store item. That's not actually what's gonna happen. At runtime, it's going to essentially change behavior depending on what object is being executed at any point in time. So that print hello is not gonna print hello, I'm a store item alone. It's gonna print or ever is gonna print based on whatever is here. So I'm gonna just compile and see what I'm talking about. So see, it says hello, I'm a food. Hello, I'm a food. Hello, I'm a consumer product. Hello, I'm a consumer. Hello, I'm imported. Right? So that's polymorphism in a nutshell. It's basically the whole idea of basically objects being able to take on many forms. So you have the store item object here. This being able to take on, or methods being able to take on many forms, or exhibit different behaviors based on what object, or basically a specific object that's being executed at runtime. The whole point is that at runtime, it's the method that is overridden is the one that is going to be called, right? So it's the one that is overridden inside the actual class, so these, that's going to be called. So essentially, whenever you say something like, where are examples of overriding or whatever, just look for examples like this, where essentially we're calling some method that is overridden in like various classes of some single type. So that's an example of polymorphism. So this is an example of polymorphism. The calc final price print hello would exhibit polymorphism as well because the behavior of this method changes based on the current object being executed by the Java runtime. Right? So that's the answer to um, what pieces of code is polymorphic. This method is polymorphic, or it's going to exhibit polymorphic behavior, and this method is going to exhibit polymorphic behavior as well. Also, the fact that I can do something like this, store item to find equal new food, is an example of polymorphism. I could have declared this food differently. I could have said food to find equal new food, and it would still work because this to find a food is not just a food, but food can also be classified as a store item. All right, so it's polymorphism in a nutshell. Polymorphism, examples of polymorphism is actually method overload. Method overloading is actually a form of polymorphism as well. Because of course you have the same method name, but you can have different behaviors dependent on the data types that you pass into the function. Um, yeah, so those are the types of polymorphism. Um, yeah, that's it for the tutorial. Any questions before I talk about the project?
Question.
Yeah, say any questions before I talk about the
Yeah,
project?
two questions.
Yeah.
First question is for the array list, is
Yes.
there a way that you can just get the information that was in the array into the array list without rewriting or adding it back itself?
So you're basically asking me if you can convert an array to an array list or an array list to an array.
Yes.
Yeah, there's a method called to array. Um, for it. Yeah, so if you want to convert a array list to an array, you have something called to array. Let me just look at exactly how it's used. I think there was an example of it actually being used. I'm actually try it. Mhm. Let me try it. Let me try. So store item. Yeah, that's actually a good point because that would actually have avoided me having to do this thing right here, right? Recreating this array. Well, let's see if I can create this array items one using the method that you just said. Makes sense. Makes sense. I like it. All right, let's commit this out. See what we get. Um, so it's something like this. So I think we'll have to do it after we actually add the stuff to the array list since we need the array list to put it into the array. So let's try this. So I think we say something like items two. Oh, it's items one is equal to items two dot two arrays. Yeah, this should be two arrays. Well, let's see that compiles. Oh, well, oh, yeah, probably not going to work. Well, let's see. All right, so it's an object cannot be converted. All right, let me try casting thing because I think it returns type object. So um, store item. Let me try doing that then. So ah, well, let's see if we get the same output. Ooh, what? Oh, the system.
You can try do the array first and then you convert the array into the array list.
Array to array list. The array list should be easy. There's something I'm missing. Mhm. Uh, oh, okay. Yeah, I see it now. Yeah, so what you can do is actually, yeah, I forgot that came in. Is actually create the array. So here we created the array. It's a new store item. Um, log. Is it a bug? Anyways, for the size, we just put whatever the size of the array list is, right? Uh, Let me comment this out. And then when I say items to array, I can pass to this items one. So basically I can pass array that I want to put the stuff from the array list into. So that should work. Yeah. Yeah, works. Yep. No
All right.
errors.
So if you have an
Yeah.
empty line in the array list index, if you have an empty index,
Yeah.
how I remove that when I'm passing it into the array or vice versa?
It's so similar. I mean, empty index. What do you mean by empty index?
Like an index with the value zero value, just set up zero the value.
What you can do is like a loop, so something like this, right? I guess probably this is a good time to transition into the project. So let me actually just open it. Uh, well, you guys have the project in front of you. Let me just go on Google and see if I can look at it. Um, I think I recognize the question you're asking. It relates to the address class, isn't it? Right?
Yes,
The fact that it's supposed to split the thing. Yeah, it's supposed to split the thing, and then basically in the two string or whatever, it basically it's supposed to remove the empty strings.
yep.
All right, so let me just quickly go to the project and I guess clear up any inconsistencies people might have. All right, well, before I answer that question about the thing there, is there any other is there any other questions people have regarding the project? Like there's a question that people don't quite understand what they're asking you to do or whatever.
What I don't understand is why we even have this Civic doc and biometric interface in the code in the first place.
Yeah,
Because it seems like
mm,
something that should be done later on down in a different
yeah, it
environment.
should
So
be.
I don't know
You
why we
actually
need to
don't need it. You actually don't need it for this part. You could leave it out and
exactly.
the all the tests would pass. Like you literally don't need to put in.
That's what I
Um,
was,
which is why he was saying that just create some stub methods, meaning you don't have to implement the code, just have the methods here.
and the
But
funniest thing about it is those sub methods have been giving some people problems because most
but
people don't
like
understand.
for the citizen, since
Mm,
it extends person is abstract and the
yeah.
person implements biometric, it
Mm-hmm.
told me I need to implement my biometric method because citizen is not abstract. And when I made citizen abstract, problem. So
But
Oh,
my question to that, Jante, did they say you're supposed to implement biometric, or is it that
all right.
biometric was
Let me
supposed to be
just
an attribute?
let me just put this out there. You can ignore anything to do with biometric for this part, because you can see the mark scheme has nothing to give you marks for implementing the biometric interface or whatever. That's the part two. So you can leave it in there if you want. If it's